In problem 51, we want to see if these two quantities are equal to each other. The first quantity is the intersection of A and B, and then take the complement of that. And the second quantity is the complement of A union the complement of B. So let's start out with the intersection. Down here, if we go with what's inside the parentheses and then build our way to outside, that's probably easiest. So the intersection of A and B down below here, this is everything that's in A, this is everything that's in B. So this right here is the intersection of A and B. Now what does the complement of that look like? The complement of that intersection means everything in the universe that's not in this intersection. Well, what does that look like? That looks like everything outside of it. So we have a little empty space in here, in this little intersection part, and everything else is filled in. So this is a picture, admittedly a kind of messy picture, but it's a picture of this quantity. And the question is this the same quantity over here? So we have A, the complement of A. Now what is the complement of A? The complement of A is everything outside here. So this is the complement of A. So that's A complement. And this is going to be the complement of B. It's everything outside of B. Now when we union these two together, we're trying to find all the points that are one or the other or both, and that's a little tricky to think about. I mean, all these points right here are in one of them, so they count. And what's added on by this picture down here is these points. And so what do we have? Do we in fact have this picture over here? And the answer is yeah, we do. Another way to look at it is what's not in the union of these two? What's not in the union? What's not in the union is anything that's empty in both. Well, the thing that's empty in both is this. And so that's the thing that's not in it. Everything else is shaded, and that describes this picture. So these two are equal. On problem 53, we discovered that this is a picture of the union of the complements of A and B. The union of the complements of A and B turned out to be everything in the universe except the intersection of A and B. And so then the second part of 53 is to compare this to the intersection of A and B. Well, again, in problem 51, we had the intersection of A and B as this. The question is, are these the same sets? And the answer is no. In a sense, the opposites. I mean, this is everything in the intersection. This is everything outside the intersection. So these are not the same shaded parts. In fact, they fit together to make the whole universe. So they're sort of complements of each other. In problem 57, we're again trying to figure out if two different sets are equal. And so in the first set, we'll do B union C. And B union C is everything inside B and C. And then we want A intersect B union C. So we want the intersection of A with B union C. And where do they overlap? Well, they overlap in these three parts right here. So these three parts are a picture of the intersection of A and the union of B and C. It's where these two overlap. Sometimes you can do these on your own without doing the preparatory work of drawing these, but drawing the separate ones and then putting them together is probably the best. So in this second part, the intersection of A and B union with C, I'm going to try to do it all at once. What does the intersection of A and B look like? Well, the intersection of A and B is this piece right here. And we're going to union that with C. We're going to combine it with everything that's in C. in this part that overlaps, we don't really count it twice. So think about this. Is this everything in C? Yes. Is it everything in the intersection of A and B? Yes. So now does this set look like this one? And the answer is no. So these are not equivalent. B union C is everything in B and C. That's B and C circles all filled in. And we want the overlap or the intersection of that with the circle A. So these guys right here are everything that is in A that is also in B or C. But what about this? This intersection seems to be the same pieces but in the opposite order. So the question is this intersection commutative? And so this is everything that's in the circles B and C intersected with the stuff that's in A. And once again, that's exactly the same pieces. These are the pieces that are both in A and in the union of B and C. And so on problem 59, the answer is yes. These two sets are the same.